So now we are going to start our 45 question assignment on wave optics and electromagnetic waves. First problem is from 1999 AIPMT. Wavelength of light is given. A wavelength of light we want to find. Frequency is given. We know that speed of light 3 into 10 to the power 8 meter per second. Frequency is given 100 hertz, all SI units, and we know that V is equals to n lambda, means C is equals to F lambda. So lambda should be C by F. 3 into 10 to the power 8 divided by 100. So what we are getting? 3 into 10 to the power 6 meter. So we will go with option B. Next, it is from 2002 AIPMT. The velocity of electromagnetic wave is parallel to. We know that waves are moving perpendicular to both E and B. So correct option is B, E cross B. E cross B will give you the direction of propagation of wave. So we will go with option B. Next, the velocity of electromagnetic radiation in a medium of permittivity epsilon naught and permeability mu naught is given by. We discussed in theory part that velocity of electromagnetic radiation in a medium are given by 1 upon mu naught epsilon naught square root of. So we are going with A. Now we are going to solve the fourth problem, which is from 2009 AIPMT. Two options are missing, but we will check what we can tell about this. Since we are using in bracket X, it means wave is moving in x-axis direction along, and it is minus means it is moving in positive direction of x-axis. These will tell you in which direction wave is moving. If at this place plus sign is there, it means negative direction of this axis wave is moving. So opposite of this sign, along this axis waves moves. So direction we got along x-axis direction. Frequency, we know that with t we write omega. So in place of omega, what we are getting? 2 pi into 10 to the power 6. But you know that omega is 2 pi f. So what we are getting? F is 10 to the power 6. So frequency 10 to the power 6 hertz. Direction along x-axis. What next we can find? Amplitude. Amplitude of vector is 2.5. And with x, there is k. And what is k? 2 pi by lambda. So in place of 2 pi by lambda, what we are observing here? With k, it is pi into 10 to the power minus 2. So cancel pi with pi. So what we are getting? We are getting wavelength is equals to 2 upon 10 to the power minus 2, means 200 meter. So all is given in B. So we are going with B option. Next, the electric field of an electromagnetic wave in free space is given by E is equals to 10 cos 10 to the power 70 plus kx j volt per meter, where t and x are in seconds and meters. It can be inferred that the wavelength, k, amplitude, direction. See, we are observing here plus sign. It means wave is moving in the negative direction of x-axis. So fourth option is wrong. It is amplitude. It is amplitude. Amplitude is given 10 volt per meter. So it means third option is correct. If you want to check another option, we can check. In place of k, no number is there. So wavelength, first we will go with this t, omega. In place of omega, we are observing 10 to the power 7. Omega is 2 pi by lambda, or 2 pi by t, or 2 pi f frequency. Frequency, no option is there. So 2 pi f is equals to 10 to the power 7. So frequency, you will get 10 to the power 7 by 2 pi. Wave number k. K is 2 pi by lambda. By frequency, you can calculate lambda because we know that speed of light, speed of electromagnetic waves, we know that. So C is equals to F lambda. So lambda we can calculate C by F. What is C? 3 into 10 to the power 8. What is F? 10 to the power 7 by 2 pi. So what we are getting? 10 to the power 7 by 3 into 10 to the power 8 is equals to 2 pi by lambda, and 2 pi by lambda is k. So this implies k is equals to 10 to the power 7 with power 8. So we are getting 1 by 30. K we are getting 1 by 30. 1 by 3 is 0.33. So it is 0.033. So this option is also wrong. Wavelength we can calculate from this. What is wavelength? Wavelength we are getting from here, you can calculate wavelength. 3 into 10 into 2 pi. 2 pi means 6.28. It means due to this 10, we are putting after one place 188.4. So it means first option and third option both are correct. So it should be a multiple choice option. Means first option is correct and third option is correct. Next, it is from 2007 and 1994 AIPMT. The electric and magnetic fields of an electromagnetic waves are, they are vibrating in same phase, because I show you the equation. No phi was there. It means they were vibrating in same phase but perpendicular to each other. So we will go with option C. Which of the following radiation have the longest wavelength? I give you the list. You have to learn that list. Radio waves has lowest frequency, means longest wavelengths. Eighth, it is from 1992 AIPMT. The structure of solids is investigated by using, we have to learn the uses of electromagnetic waves. So you will find the structure of solids is investigated by using X-rays. Next, it is from 1994 AIPMT. Which of the following electromagnetic radiation have the smaller wavelength? Means in this, which have smaller wavelength? Smaller wavelength means high frequency. So between X-rays, ultraviolet rays, microwaves and gamma rays, the smallest wavelength is of gamma rays. Next, the frequency order of gamma rays, X-rays and ultraviolet rays, frequency order of this. So it is BAC, means the frequency is maximum with gamma rays. Just I told you, due to high frequency, smaller wavelength gamma rays have. Then ultraviolet rays, and then these are coming number. First gamma rays, highest frequency, then X-rays, then ultraviolet rays are coming there. Next, it is from 2001 AIPMT. Biological importance of ozone layer. Everyone knows that today it is a question of GK also. Ultraviolet rays, why they are useful for us? They are stopping ultraviolet, ozone layer is stopping ultraviolet rays. So we are going with A. 2002, 12th. What is the cause of greenhouse effect? Greenhouse effect is from 8th, 9th class. They are putting in syllabus. That is due to infrared rays. 2003 AIPMT. Which of the following rays are not electromagnetic waves? You know that beta rays are rays formed by electrons. So all other are electromagnetic waves except beta rays. They are fast moving electrons. Again from 2003 AIPMT. We consider the radiation emitted by the human body. Which one of the following statement is true? The radiations coming from human body, according to wavelength, they belongs to infrared region. They belongs to infrared region. Next, it is from 2005 AIPMT. Lambda V, lambda X, lambda M represent the wavelengths of visible light, X-rays and microwaves. Again, due to frequency, you can find which have maximum wavelength, which is in second number, which is in third number. So we are going with option C, means microwaves wavelength maximum, then the number of visible light is there, after that X-rays are there. 1988. Which one of the following phenomena is not explained by Huygens construction of wavefront? It is explaining refraction, it is explaining reflection. Huygens explained actually wave nature of light, but didn't talk about origin of spectra. So we are going with D. 1989. Interference is possible in. We studied it in light also. We studied this topic in sound also. So you know that both light and sound waves, they are showing interference. Even both showed diffraction also. Diffraction in sound wave easily you can observe because wavelength of sound waves is greater than wavelength of light waves. So in general practice you can observe the phenomena of diffraction easily in sound. Next, 1991 AIPMT. The ratio of two waves is given by 4:1. The ratio of amplitude, we know that intensity is directly proportional to A square. It means I is equals to some constant into A square. It means I upon A square should be constant. For all waves, I1, for one wave, I1 upon A1 square. For second wave, I2 by A2 square. It should be constant. Since in this problem, I1 upon I2 is given and we want the ratio A1 by A2. What is given? I1 by I2 is 4:1. It means A1 square by A2 square is 4:1. Taking square root, ignoring minus sign, amplitude cannot be negative. We are getting 2:1. So we are going with option A. 19th, it is from 1993 AIPMT. Interference was observed in interference chamber when air was present. Now the chamber is evacuated, and if the same light is used, a careful observer will see. You know that the refractive index of air is little bit greater than vacuum. Vacuum, it is exactly 1. So it means we are decreasing the refractive index. And what is wavelength? Wavelength for vacuum. You know the formula of refractive index for any medium. It is speed of light in vacuum upon speed of light in medium. Not writing air, I am writing vacuum. And V is equals to n lambda. Frequency is same. So wavelength in vacuum upon wavelength in medium. So what we are getting? Ki in any other medium than vacuum, what you will get? You will get, for every medium mu is greater than 1. So if we are removing the air, it means we are decreasing the mu. For air it was greater than 1, for medium it was exactly 1. So if you are decreasing the mu, means you are increasing the wavelength, and fringe width is directly proportional to wavelength. If you are increasing the wavelength, it means you are increasing the fringe width. So interference in which width of the fringe will be slightly increased. So we will go with option D. Next is from 1995 AIPMT. In a Fresnel biprism experiment, the two positions of lens given separation between the slits as this and that. What is the actual distance? We know the formula for actual distance. It is under root d1 into d2. So d1, d2 both are given. One is 16, another one is 9. So what we are getting? Root 144 means 12 centimeter. So we will go with option D. Next, it is from 1999 AIPMT. Color appear on a thin soap film and on soap bubbles due to the phenomena of, I explained you in theory, कि it is due to interference, reflection from front surface and reflection from back surface. Due to front and back surface, there is a difference in path. So due to path difference, interference will take place and you will get colors in thin soap film and soap bubble. Next, it is from phase 2 2016 AIPMT. The interference pattern is obtained with two coherent light sources of intensity ratio n, means what they are giving? I1 by I2, two light sources whose intensities are in the ratio n:1. We want to calculate I maximum minus I minimum upon I maximum plus I minimum. We calculated in theory parts that I is proportional to A square, and at the time of maximum intensity, amplitude was A1 plus A2, and at the time of minimum intensity, we have derivation in just today's theory part, A1 minus A2 whole square. It means I maximum upon I minimum is equals to A1 plus A2 whole square upon A1 minus A2 whole square. By componendo dividendo, we are getting I maximum minus I minimum upon I maximum. What you are doing in left hand side, same do with right hand side. We are taking difference of numerator denominator, so in this side we will do that. Denominator we are taking sum, so we will take here also. A1 square plus A2 square will cancel out and you will get 2A1 A2 plus 2A1 A2. What we are getting? 2A1 A2 at this place, 2A1 A2 at that place. So we will get 4A1 A2. Here plus 2A1 A2 minus 2A1 A2 cancelled out. You will get twice of A1 square plus A2 square. So we are getting 2A1 A2 divided by A1 square plus A2 square. Take A1 A2 and denominator of denominator. So you will get I max minus I min upon I max plus I min. A1 square upon A1 A2, we will get A1 by A2, or you can say dividing numerator and denominator by A1 A2. Here you will get A2 by A1. We know that I1 upon I2 is equals to A1 square by A2 square. So this implies A1 by A2 is root n. So what we got here? 2 upon root n plus opposite 1 by root n. Take LCM and put this root n in numerator. You will get n plus 1. So we are going with option C, 2 root n upon n plus 1. Next, it was from 1990 AIPMT. The Young's double slit experiment is performed with blue and green light. If x is the distance of the fourth maxima from the central one, then we know that either it is maxima or it is minima. Distance from central is directly proportional to wavelength because in that lambda is in numerator. So if wavelength is more, distance should be more. What is the wavelength? More wavelength is for green light. So you will get x more for green. It means we will go with option C. Next, it is from 1990 AIPMT. In Young's double slit experiment, the fringe width is found to be 0.4 millimeter. If the whole apparatus is immersed in water of refractive index 4/3, without disturbing the geometrical arrangements, the new fringe width will be, we know that fringe width is given by d lambda by d. Initially, your experiment was in air. Now, without disturbing geometrical arrangements, means capital D and small d are same. you take your apparatus in another medium. So due to change in wavelength, you will get different width. What is the relation of new width with old width? What you will get? You will get d and d will be cancelled out. Lambda m upon lambda a. But we know that refractive index of any medium is wavelength of light in air or vacuum upon wavelength of light in medium. So lambda a upon lambda m is mu m. So lambda m upon lambda a is equals to 1 upon refractive index of medium. So what we are getting, W dash is equals to W upon mu m. In this problem, refractive index was 4/3. So we will get new fringe width 3/4 of old. Old was 0.4 mm. So new should be 0.3 mm. So we are going with option A. We are going with option A. It was from 1990 AIPMT. Next. It is again from 1991 AIPMT. In a Young's experiment, two coherent sources are placed 0.90 mm apart, means small d is given. If you want to do in SI units, 0.90 into 10 to the power minus 3 meter. And the fringes are observed 1 meter away, means distance between slit and screen is given 1 meter. If it produces the second dark fringe at a distance of 1 millimeter, for dark fringe x is given. For second dark fringe 1 millimeter means 10 to the power minus 3 meter. We want to calculate which wavelength of light we used. In case of dark fringes, we know that xn is equals to 2n minus 1 d lambda by 2d. N is given 2. So by putting it 2, we got for second dark fringe, it should be at a distance 4 minus 1, 3 d lambda by 2d. This implies lambda should be 2dx2 upon 3d. So what we are getting for lambda? 2. D was 0.90 into 10 to the power minus 3. x2 10 to the power minus 3 upon 3d. We are getting in meter, but all options are in centimeter. So by multiplying by 100, we will get our answer in a centimeter. Now only calculation is there. Remove this decimal with this 100. You will get 90 by 3 means 30. So 30 into 260 into 10 to the power minus 6 cm, or you can write 6 into 10 to the power minus 5 cm. So we are going with option D. We are going with option D. Next, 26. It is from 1992 AIPMT. In Young's double slit experiment, carried out with light of wavelength 5000 angstrom. What is given? Lambda is given. 5000 angstrom means into 10 to the power minus 10 meter. The distance between the slits is 0.2 millimeter. D is given. Screen is at 200 centimeter. D is given. The central maxima is at x is equals to 0. Okay. The third maximum will be at x is equals to. For maximum, we want to calculate x3. What is the formula for maxima? Xn is equals to n d lambda by d. So for third, it should be 3d lambda by d. D is 2, lambda is 5000. By d. What is d? 0.2 into 10 to the power minus 3. We are getting our answer in meter. So in centimeter, it should be multiply by 100. It is centimeter now. Remove this decimal, you will get 10 in numerator. Minus 3 will become plus 3, cancel 2 with 2. So what we are getting? 5 into 3, 15. Into 10 to the power, see, 3 0, these are plus, 3 and 3 is 6, 6 and 2 8 and 1 9, so we are getting minus 1. It means 1.5 centimeter. So we will go with option B. We will go with option B. 27th, it is from 1992 AIPMT. If yellow light emitted by sodium lamp in double slit experiment is replaced by monochromatic blue light of the same intensity, what will happen to fringe width? We know that in our spectrum, wavelength is in decreasing order. According to wavelength, it is decreasing order. Red color has maximum wavelength. It means wavelength of yellow should be greater than wavelength of blue. And fringe width is directly proportional to lambda. So fringe width of yellow should be greater than the fringe width of blue. So if you are replacing the yellow color by blue, it means you are decreasing the fringe width. So we are going with option A. Next, it is from 1993 AIPMT. A parallel beam of monochromatic light of wavelength 5000 angstrom is incident normally on a single narrow slit of width 0.001 millimeter. The light is focused by a convex lens on a screen placed in a focal plane. The first minima will be formed by the angle of diffraction equal to, we know that, A sin theta. For minima, A sin theta is equals to n lambda. For first, n is equals to 1, it should be lambda. So what we are getting? We are getting sin theta is equals to lambda by a. Sin theta is equals to lambda by a. We have the value of lambda 5000 angstrom. Angstrom means 10 to the power minus 10 meter. It is 0.001 millimeter, means 10 to the power minus 3. Same unit will cancel the unit. Sin theta has no unit. So what we are getting? Numbers are only 2, 5 in numerator, 1 in denominator. What is the power of 10? 30 plus. When you remove this decimal, you will get 30 in numerator, 6 and 3 9 zeros. So it will become minus 1. So we are getting 5 by 10. Means 1 by 2, which is the value of sin 30 degree. So we are getting theta is equals to 30 degree. So we will go with option C.